The way we've talked about innovation in the past has, in my view, misled people, young people in particular, into thinking that it's a special creativity, a sort of special juice that flows in the veins of these people that makes them into semi-gods, that these guys were so smart. We're actually putting kids off. We're saying, you can't be one of these. You're not a genius. And actually, in the end, all you need is perseverance. And anyone can do that.
Right.
So one of the things I want to do is democratize and demystify innovation.
I'm Brandon Vaidyanathan, and this is Beauty at Work, the podcast that seeks to expand our understanding of beauty, what it is, how it works, and why it matters for the work we do. This season of the podcast is sponsored by Templeton Religion Trust and is focused on the beauty and burdens of innovation. What makes beauty such a powerful force, both in nature and in human creativity? Why do birds evolve dazzling displays that seem to defy survival? And what can that teach us about the way innovation happens, both its beauty and its burdens? I'm absolutely thrilled to welcome to the show today Matt Ridley, science writer, journalist, and author of numerous best-selling books, including The Red Queen, Genome, The Rational Optimist, The Evolution of Everything, and How Innovation Works. His books have sold over 1 million copies in 31 languages. He served in the UK House of Lords, created the Wall Street Journal's Mind and Matter column, and is a fellow of the Royal Society of Literature, the Academy of Medical Sciences, and a foreign honorary member of the American Academy of Arts and Sciences. In our interview, we're going to focus on 2 of Matt's books, his latest book, Birds, Sex, and Beauty, and How Innovation Works. We're going to unpack Darwin's theory of sexual selection, why he thought beauty can drive innovation. And from there, we're going to pivot to talking about innovation, why it's mostly incremental and collaborative, how basic science and technology can and should cross-fertilize, and why freedom and openness matter. We're also going to look at why Matt is mostly bullish on innovation despite its burdens. Let's get started. All right, Matt, thank you for joining us on the podcast. It's such a delight and honor to have you here.
Thank you, Brandon, for inviting me.
Great. Well, we like to get started with every episode by asking guests to reflect on a moment of beauty from their childhoods that lingers with them till today. Is there anything in particular that comes to your mind?
Well, from childhood, that's interesting. I think I'm going to say sitting on the shoulders of my father and opening a bird box, looking in to see a bird's nest inside.
Wow.
There's something very attractive about birds' eggs, the color of them, the brownness of the sort of jewel-like nature of them, but also the nest, because most have probably been a great tit or a blue tit nest, which are 2 birds that nest in nest boxes where I live, and they line their nests with feathers. So nests are beautiful things, incredible constructions by birds, very characteristic. Each species does it differently. And the eggs are just gorgeous little attractive things. So I have a memory of that's sort of what got me hooked on bird watching. I think was my father taking me around to look in nest boxes and see which birds had been laying eggs in them.
Wow, Matt, you've had a really rich and varied career, but the study of birds and spending time observing them has been a practice for quite some time. Could you talk us through a little bit of your journey through the world of journalism, economics, and some of the books you've written, but how this particular fascination with the beauty of birds has still animated you along the way?
Yeah, well, it's a sort of, not a straight line, but it's a sort of line. It starts with getting interested in bird watching through my dad as a small boy. That got me interested in biology. Biology got me interested in evolution in particular. Evolution became a topic of study for me, and from there I moved into science writing, but was always very intrigued by the parallels between sort of evolution of biological systems and evolution of society, which you might call economics, if you like.
Right.
After a while, I became science editor of The Economist, but then I moved to do political reporting for The Economist and became American editor based in Washington. Then I decided I wanted to write some books, and the first book I wrote was about evolution, about the subject that I'd really done my DPhil on, which is the evolution of sex and sexual reproduction generally. But that got me into book writing, which then got me into other evolutionary books. That led to books about genetics and genomics, and I wrote several books about that subject. That then got me intrigued in the parallels between genetic mutation in biological systems and innovation in economic systems. So I then kind of switched to writing about innovation, which I did in 2 or 3 books. I've sort of written 3 books on genomics and 3 books on innovation. It's like I write 3 books at a time.
Okay. Great.
And then just recently, I've gone right back to what I did my PhD work on, which is the topic of sexual selection, the evolution of brightly colored plumage in male birds in particular, and how puzzling it is, but also how fascinating and how different from other forms of evolution. And so that's kind of the trajectory of my career and my interests. I've done other much less relevant things along the way, but that's the thread, if you like.
Yeah, no, that's remarkable, and yeah, no, your books have been tremendously influential. And well, let's start with maybe your most recent one on bird sex and beauty. And I was just struck by the remarkable amount of effort it takes to go and watch these leking birds. Could you talk a little bit about the black grouse and what a lek is, and just give us a description of like what does it take to go and see this ritual happening?
Yes. Well, the black grouse is one of these birds that does this rare and spectacular thing called leking, where the males all gather in the same spot every day at dawn, both fight and dance for the benefit of females which visit for a few days. And the males do it for months on end, but the key moment is in the middle of spring when the females are likely to visit and it reaches an intense crescendo. And unlike almost every other wildlife experience, you know exactly where to be and when to be there. Normally, you're lucky to see a lion killing a zebra or whatever by chance. But in this case, you know exactly which couple of weeks and which time of day and which spot to be in. And it's the same spot every year and every day. So that's really wonderful. But the action happens an hour before sunrise to an hour after sunrise.
Right.
And mating is usually pretty well around the time of sunrise. Don't know why, it just is. And this is late April in northern England when we're already well past the equinox. So sunrise can be 5 o'clock in the morning or 5:30 or something like that. So you have to get up at 4 or 4 o'clock even and get out of bed. And it's usually pretty cold at that time of the year. Can be frosty, can be snowy even, quite often rainy or windy. So you've got to put on a lot of clothes because you're not going to be moving around. You're going to be sitting still for a couple of hours. But we've habituated a couple of these leks so that the birds are used to our presence. They wouldn't like it if we were just standing there, but if we're in a vehicle or we're in a hide, a little tent, then they're completely relaxed and we can move around, not loudly or conspicuously, but if we just sit there with the windows open, we have this special vehicle where you can lift the windscreen open so that you're looking forward. Then you can, almost as close as I am to the screen that's in front of me here, and you can see everything that's going on. Up to 20 male birds displaying extraordinary plumage, indulging in bizarre dances and making strange noises, and then getting terribly excited when females come, and females wandering around looking nonchalant. How do we know what's really going on inside their heads?
Right.
And then deciding which one of the males they want to mate with. I think it's as spectacular a wildlife experience as I know. It happens not very far from where I live, so I can make a habit of being there many, many days of the year. It wrecks your sleep and your social life a bit for a few weeks, but it's worth it.
Yeah, no, it's just extraordinary the descriptions you provided of this, and it's striking that the scientists have been doing this for quite a while now, more than a century, with Cillis and the others who've been. Unfortunately, Darwin didn't see any leks, but I'm curious
Yes.
about
Yeah,
your
I was
yeah.
fascinated by that because he knew the species quite well and he used to shoot them occasionally and eat them when he was a young man. And it's a very rare bird now, whereas it was quite common in his day and lived all over England. Now it's just confined to a small part of northern England. Yeah, I have this curious criticism of the Victorian naturalists who saw what they wanted to see.
Right.
they saw a jousting tournament in which one male is left victorious and the others leave the field, and then
Yeah.
that's how it's decided who's going to mate. Well, that's just not true. They're all
Right.
still there, and each has his own little patch. And it's every fight is a kind of stalemate, and the decision as to who gets to do the mating is not the male's decision at all. It's the female's decision, and that's something the Victorian naturalists didn't want to see, and therefore didn't see.
Yeah, this example really, I think, remarkably paints this tension between the reigning account of natural selection and then the account of sexual selection that Darwin was trying to develop, and then couldn't quite succeed in convincing people. Could you talk a bit about the difference between those two mechanisms and perhaps how they run counter to each other and why it was that Darwin struggled to convince people about this?
Yes. Well, just last week, I was having a conversation with an evolution biologist who took exception to my saying that sexual selection is very different from natural selection. No, 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 it's not. You can't say things like that. The creationists will latch onto it, he said, and things like that. I don't think that's true, by the way. But Wallace, Alfred Russel Wallace, Darwin's co-discoverer of natural selection, took the view that sexual selection is nothing special. It's just a branch of natural selection, because what's happening is that the females choosing the healthiest males, and so that's just the colourful nature of the males is just a way of the females getting healthy genes for their offspring. That's the view that prevailed even during Darwin's lifetime and throughout most of the 20th century. Darwin did not think that, and he had a big disagreement with Wallace over this, and I think it was quite painful for him that he wasn't able to persuade Wallace. And the year 1868 in particular, when he's building up to writing The Descent of Man, which is his book almost entirely about sexual selection, he spends a lot of time trying to persuade Wallace of his view and fails. And essentially what Darwin is saying is, I can explain the evolution of complex organs like the eye through natural selection, very small incremental steps leading to improvements in the technology of something like an eye, step by step over millions of years. But I can't explain a peacock's tail because it serves no practical function. If anything, it's a laborious burden for the animal to carry around. It makes it more vulnerable to predators. It's beautiful, and that seems to be a big part of its importance because the male fans it out and displays to the female with it. So clearly there's something going on here that can't be explained in terms of helping the animal survive. It's not survival of the fittest. And he wrote this letter to Asa Gray in 1860 where he said, the sight of a peacock's tail when I gaze upon it makes me feel sick. And that's what he meant, I think, because he was worried that he didn't have a good explanation for this, because his critics had a very good explanation, which is that peacock's tails were put on Earth to please human beings.
Right.
And so is every other form of beauty. And that was quite good enough for them and for most Victorians and most people who are theological about these things. He says, I think what's going on is that females have an inherent aesthetic sense. They just like beautiful things, a bit the way we do. I don't really know why they do, but they do. And so the male has to grow beautiful plumage if he's to succeed in mating. Now, that wasn't a terribly convincing theory, as you can see, because it kind of says, well, why? And he never had a good answer to that. And the good answer came long after his death with the work of a man named Ronald Fisher, in my view. And what Fisher said was, if you think about it, if the females are indeed preferring gaudy, colourful males, then they've got to be quite careful not to mate with the wrong male, or they'll have sons who can't get laid, basically.
Right. Yeah.
So this is the cheap version.
The sexy son hypothesis, you call it.
Exactly.
Yeah.
Yes. So you can see that, in contrast to what Wallace is arguing, it's not the health of the offspring that is the prize. It is the sexiness of the offspring. And that changes everything, because it means we're not talking about survival of the fittest. We're talking about seduction of the hottest, if you like, which can be a very self-fulfilling prophecy. And that, it doesn't really matter what you do, what you consider hot. It can be anything. It can go in any direction. And that makes sexual selection, in my view, into a much more creative force than natural selection. It can generate eccentric and diverse outcomes in a way that natural selection doesn't. And the way I put this in a rather cheap shot in the book is I say mammals are basically brown and boring.
Right.
They don't have a lot of this sexual selection going on. Birds are brightly colored. They're red and blue and green and yellow and orange and, and they have beautiful feathers and they do beautiful displays. I mean, they must think we are terribly boring creatures.
Right.
When they look, we grunt.
Right.
Well, human beings sing, but most mammals don't sing. Birds do. Think of all the sort of beauty that birds devote so much effort to, the song and the display and the colors and everything, that most mammals just don't do. And that's because of sexual selection, mate choice, and that, off I go into saying I wish I was a bird, and maybe I sort of am in an honorary way.
Right. So, do you get an objection that how do we really know what these females are observing in these males? Because we can't really see all the things they see, etc. And to what extent are we aware that their discernment is based on aesthetic criteria rather than something we're not able to observe by virtue of being humans, for instance?
Yes, and my view is still a minority one. Most people think that if we look hard enough, we're going to find that the male the females prefer to choose on a lek is the one with the least mutations or the least parasites or something like that. And there is actually some good new evidence that might be the case in black grouse. So I might be wrong. But that can be true at the same time that what the female is after is pure aesthetic appreciation, because that will enable her to have sexy sons. Both could be true. They don't have to be opposites. Now, there have been quite a lot of experiments where they've done things like add extra length to the tails of long-tailed birds. That was a brilliant experiment that Malty Anderson did in the 1980s with a bird called the widow bird in Kenya. And he found very clearly that if he made these long tails even longer by cutting bits off another bird's tail and sticking it on the end, then he could increase that male's mating success. So it does seem to be true that the females are seduced by good versions of the display, as it were. And there's various evidence of manipulation experiments, etc. And there were even attempts to sort of put the video camera on the head of a peahen and film what it was she was looking at when she was looking at a male displaying. They were fairly inconclusive, those experiments, but you get the idea that there's this kind of thing is going on. Funnily enough, the experiment that comes closest to proving Fisher's hypothesis right was done with flies that had a particular, I think they're called stalk-eyed flies. The eyes are out on stalks either side of the head. The wider the stalks, the more attractive the flies are to females. By deliberately breeding from the unfancied males for generation after generation, the scientists were able to test, do these unfancied males have unhealthy offspring, or do they have unattractive offspring? And mostly they had just unattractive offspring.
Right. Yeah.
They often got less and less attractive to females, but they didn't get less and less healthy.
Yeah. I mean, another thought perhaps is if they are selecting on just these aesthetic qualities, wouldn't over time you see a weeding out of some of the unattractive features, right? And you would get sort of more of a clustering around a very similar set of aesthetic qualities that have been selected for over time. But we just do still see a lot of diversity, and a lot of these birds on these leks are not getting laid, for instance, right? And I wonder if you have thoughts on what might be at work there.
Well, you say that, but actually to the human eye, if I take the black grouse, the one that I watch most closely, it's very hard to distinguish the males. You look at these guys occasionally. I mean, there was one who I write about in the book. In fact, I dedicated the book to him. He was called Wonky Tail because he had some spinal deformity that meant that his tail was at that angle rather than that angle. We saw him come back year after year for about 4 years, and then the last year he was really not at his best, and he disappeared after a while. And I saw him get one mating, but he never got the jackpot. He never got to be the top male before lots of matings. But apart from that, and the odd missing feather or the odd blemish that enables you to distinguish individuals, I got to know individuals because I got to know exactly which little territory they occupied on the lek. But I couldn't really say, that one's better looking than that one. So the differences were pretty subtle. And that's often the case if you look at birds of paradise and things. On the whole, they look pretty similar. What is very striking, and which I think you were possibly also getting at, is that it can be any part of the plumage that gets exaggerated in different species. Oh, but all of the bird is sort of exaggerated in some way. There's no bit of the bird is left boring and brown in these sexually selected species. But in some birds, the tail is long. In some birds, it's funny shaped. In some birds, the main color is red. In some, it's black. In some, it's blue. Etc. Etc. The song can be one kind of song or a different kind of song. So there doesn't. If it was about illustrating health, then I think it would all converge on, look, the best way of illustrating health is always to try and grow red feathers and always to try and grow long feathers. That's the best way, etc. And it doesn't seem to be like that. It seems to be capable of going off in any direction. Actually, the way you put it, which is that there is variation still, despite all this highly selective nature, leads to another point, which is sometimes known as the lek paradox. These birds are very selective. That is to say, on the lek that I watch, one male will get, 18 matings, another male will get 2, and the rest will get nothing. So that's narrowing the gene pool in every generation. And all the males and females in the area the next year, well, not the females because they tend to move away, but all the males in the area the next year will be half brothers.
Right.
Or a lot of them will. What's the point of being so selective? These species are way more selective than most birds, where, they pair up and they say, you're good enough. Yeah, I'm going to settle down and bring up a family with you. These guys say, no, I want that guy.
Yeah. And everyone, like this seems very mimetic around the females all opting for this one, right?
Well, that's the other thing. Are the females copying each other? Right. And there seems to be some evidence that they are. They kind of watch each other and they say, oh, he's the one we're choosing this year.
Right.
So there's a paradox here. Why are they so choosy when there's so little genetic variation among the males?
Yeah. And so the idea that there is some kind of sense that they're selecting on the offspring that would be more attractive, right? In the sense that this is why should a female prefer the most elaborate bower or bluest hoard, right? It's not about some kind of health signal, but the fear, perhaps, I don't know, how much we're anthropomorphizing here, but that their sons will be without mates, right?
Exactly. That seems to be the key. You mentioned bowerbirds, and I was thrilled to get a chance to go to Australia and watch these extraordinary birds, which really have taken it to another extreme and which absolutely vindicate Darwin's insistence that this is about aesthetics, and that actually to understand bird display, you need to understand aesthetics. And his critics said, don't be ridiculous. These are birds. Their brains are the size of peanuts. They can't appreciate beauty.
Right.
And he said, I think they do, I think they really do. And in the bowerbirds, what they've done is they've invented art.
Right.
I mean, the display is not their own plumage. It's the decorations they bring to their bower. They literally have to decorate a bower with colored objects. That's going to impress the female. So it's literally saying, come and see my etchings.
Right. Yeah, no, I mean, and it's, I know you didn't write this book in order to make some implications for human beings, but you do end up saying that sexual attractiveness could be a sufficient explanation for pretty much any human mental trait, or even, the evolution of the brain, perhaps, or the evolution of art, right? And I think you argue that it should be the null hypothesis. Could you say more about that? Like, what are the implications of this work then for how we understand our brains and even art, the evolution of art?
We devote a lot of time to art, one kind or another, whether it's singing or painting or just verbal gymnastics, if you like. We devote a lot of brain power and time to humor. We're constantly trying to impress people, particularly of the other sex, with how funny we are. It does seem to matter. People value sense of humor very highly in potential mates. We use a lot of our brain power to do things that aren't directly related to survival in any practical sense, but they are related to seduction. That's the observation that I think is worth thinking about. Now, Geoffrey Miller wrote a book called The Mating Mind about 25 years ago, which made a very powerful and very eloquent argument for the idea that we've always assumed that the reason the human brain got suddenly very big, and it was quite sudden, it seems to have accelerated in its expansion around a couple of million years ago, was because it solved a practical problem of how to live on the savannah, how to find food and survive difficult seasons and that kind of thing. Well, baboons and gazelles live on the savannah, and they don't seem to need an enormous brain. So that's not a terribly convincing explanation, really. Well, yes, but maybe it's social. Maybe we need it to solve the social problems we present ourselves. Why is he gossiping about him with respect to his relationship with her, who is being beastly about me? That kind of complex social problem, which we again do spend an awful lot of time thinking about. It's the main theme of most soap operas and things like that. So, yeah, sure, we use our big brains for that. But the third possibility is that the reason that brain just suddenly swelled up the way it did, at enormous cost, remember, because not only does it use a lot of energy, the brain, the human brain, it also kills a lot of women. I mean, to this day, there is a real struggle to get a big head out through a small pelvis. And the female pelvis has expanded in order to allow that over the years. The only way that happened was by killing a lot of women, remember. We made it hard for our species to survive childbirth, both the mother and the child. There must have been a real reward for having that bigger brain. And that reward might have been a purely sexual selection one rather than a natural selection one, which was that people with larger brains were more likely to get attractive or successful mates. Not more mates, because we're not highly polygamous species like guys. We have some degree of polygamy and a lot of infidelity and things like that, but we're much more like normal birds in that respect. We've got pair bonds and dependent young and that kind of thing, which, so I think it's a mistake. People look at the lek or read my descriptions of the lek and say, sounds just like a nightclub. Well, it's not, because in a nightclub people are trying to pair off, whereas in a lek they're trying to all decide that they're all going to make with the same bloke in the middle of the dance floor, which is not, on the whole, what happened. I gather. I haven't been to a nightclub for 40 years.
Right. Yeah, no, I don't think that's changed too much. Yeah. But it's and it's the sort of objective of this attraction could be anything, as you say, from humor to art to some quality, right, and dancing or whatever sign of prowess. But that judgment about what that is seems to vary tremendously. Yeah, I mean it's an interesting, it's really an intriguing hypothesis. One of the things that I think you mentioned is that sexual selection is also perhaps a force for evolutionary innovation. So I'd love to pivot a little bit to your book on innovation, try to understand what is innovation and are humans unique in our capacity for innovation?
Yes. Well, I sometimes put it simply. I said, what is this thing called innovation? And why does it happen to us and not to rabbits or rocks? And on the whole, we are pretty unique in the degree of innovation we have. You can find examples of crows or apes or dolphins sort of developing new habits, new tactics, new tools, but they're pretty few and far between. Whereas for you and me, we've lived through, well, I've lived longer than you, but I've lived through the most extraordinary changes in the world that I live in. And I expect a constant stream of innovation such that I have to update my smartphone every 5 years or whatever it might be. Well, not quite as often as I used to have to when it was new, but you get the point. It is innovation that is the main event of human history in the last 200 years, I would argue. Forget the wars and the depressions and the religions. The main event is the invention of the railway 200 years ago this weekend, by chance. Invention of electricity, the invention of the computer, the invention of the airplane. These are the things that have really, really changed the world. There's a million of them, and somehow we've got ourselves into a situation where we are good at doing this as a species, as a society. And it has raised our living standards. That's the reason why in my lifetime, the number of people living in extreme poverty has gone down from more than 50% to less than 10% of the world. That's an amazing thing that nobody has ever lived through before. So in my book, How Innovation Works, I set out to try and understand what innovation is, why it happens, when and where it does, and what are the general themes that emerge from it. And the way I did this, it was only once I'd started writing the book that I realized the right way to do this was to tell a bunch of stories.
Yeah.
Each chapter has about 5 or 10 stories in it of innovations that were really significant or sometimes that were failures as well. And what are the lessons you can draw from them? And the same lessons kept coming around again and again and again. Things like great inventors always talk about the importance of trial and error. They don't expect to get it right first time. They need to do a bunch of experiments and fail. Things like it's not just about inventing a prototype, it's also about making it reliable, affordable, available for people. There's a lot of innovation goes into that. Jeff Bezos made e-commerce into something that we could all use, but he didn't invent it and he wouldn't claim to.
Right.
Things like the importance of serendipity. Quite often, inventors think they're inventing something and then they invent something else. Stephanie Kwolek was the woman who invented bulletproof vests, Kevlar. That was not what she was trying to do at the time.
Sure. Yeah.
So these are the sort of themes that I pulled out. And the overarching theme, I said in the end, was freedom. That you actually need freedom to experiment, freedom to fail, freedom to try again, freedom to seek backing for your idea, freedom to move to a congenial regime where you can do these things, because quite often inventors had to leave home and go somewhere else. These are the kinds of, that's the secret sauce, in my view, of how innovation works.
Yeah. Now, one of the things that seems to be an obstacle for a lot of us is this sort of lone inventor myth, right? And I think when we think about innovation, even in companies, right, and all the sort of business books that are written about innovation, I think part of the rationale is to be able to help you to figure out how to be innovative or help your company to figure out how to be innovative. And I think it presents an idea of some kind of individual that is capable of being able to rationally intentionally innovate. And I think your account really contests that. It's much more of an evolutionary sort of unintentional, as you say, there's trial and error involved. But could you talk a little bit about is it possible to sort of engineer innovation? Can a company or an individual learn how to be innovative?
Yes, I mean, there's no doubt that some firms get it right more often than others. I think the idea of the lone inventor is a great way to get into this topic, because always it emerges that it's a much more gradual process than it looks. In other words, we give a Nobel Prize to the bloke who had the eureka moment,
Right.
but actually he was standing on the shoulders of other people. And even after his eureka moment, other people had to take his idea and develop it further. His or her. I'm not meant to be sexist here. So that's one feature. But the other feature, the way we've talked about innovation in the past, has, in my view, misled people, young people in particular, into thinking that it's a special creativity, a sort of special juice that flows in the veins of these people that makes them into semi-gods. That these guys were so smart. We're actually putting kids off. We're saying, you can't be one of these. You're not a genius. And actually, in the end, all you need is perseverance. And anyone can do that.
Right.
So one of the things I want to do is democratize and demystify innovation and say, Thomas Edison was one of the great inventors of all time. He came up with an enormous number of things, but only by setting up an innovation factory in which he employed some people who worked extraordinarily hard. He drove them, like slaves almost.
Right. Yeah.
And their job was to do a ton of experiments. He tried 6,000 different types of plant material before he settled on a particular kind of Japanese bamboo for the filament of his light bulb. Now, that's the sort of, anyone can do that. You don't have to be clever to do that. You just have to stay up at night and, get up
Right.
early in the morning and all that kind of thing, and not give up or not settle for second best or that. So these are the features. My favorite example of all this is a very, very well known one, but it does tell the story beautifully, is the invention of the aeroplane. This man named Samuel Langley, very brilliant astrophysicist, head of the Smithsonian Institution, has the ear of the US government, gets a $25,000 grant in 1903 to build the first aeroplane because he knows exactly how to do it. He's way cleverer than everyone else. He doesn't need to talk to anyone, does it in secret, and then unveils his aeroplane, puts a bloke in it, not himself, and says, off you go. And the thing goes plop into the Potomac River. And there is, the government's furious, Langley's humiliated, and the whole thing's a disaster. 8 weeks later, on a sandy island off the coast of North Carolina, two bicycle mechanics from Dayton, Ohio, without a degree between them, succeed where Langley had failed. And what the Wright brothers had done differently from Langley, and nobody believes them, by the way, for several years, actually.
Right.
Months anyway, but there's a marvelous editorial in Scientific American saying, look, if two bicycle mechanics from Ohio have solved the problem of powered flight, don't you think we'd know about it?
It's incredible.
But anyway,
It's incredible.
The point is they had corresponded with people all around the world, people who were working with gliders, with box kites, with wind tunnels, with birds, picking other people's brains. Then they'd done a ton of experiments. They'd done years of experiments with gliders. During this, for example, they'd work out how you turn right and left in the air, which nobody had thought about before. They solved that problem with gliders, not with powered planes. And only then, after 4 years of this, did they try sticking a small engine on one of these things. And the rest is history. You too could be a Wright brother. All you've got to do is spend every day for 6 months, for 4 years, tinkering with a glider on a beach, on a mosquito-ridden shore, living in a crummy hut, with your sister cooking meals for you. She had a degree, interestingly. And you're away, And of course, what kind of is what people are doing now? I don't think if you really got to the bottom of the secret behind AI today, you would find necessarily, well, this is unfair. I was going to say you won't find brilliant people. Of course you will, but no more brilliant than other people who could have done.
Yeah. Yeah, no, I think there's certainly something alluring about that sort of myth of, the genius, and then it's a heroic story, and maybe it's inspiring for some, and but it does seem to pose an obstacle for us to think about our own capacities for innovation. There are a couple of other sorts of myths, perhaps. One is that innovation is necessarily disruptive. And the concept of, Clay Christensen's idea of disruptive innovation has really captured the imagination of Silicon Valley, for instance, or that, necessity is the mother of invention, or that you need some kind of crisis or war to really generate innovation. And I think you dispel both of these. Could you talk a bit about them?
Yes, I think the search for being a disruptor has slightly misled people in recent years. And Clay Christensen may be partly responsible for that. I'm not blaming him. I'm just, but he's captured the point, because an awful lot of what's gone on in my lifetime with, for example, the internet or Moore's law or this kind of thing is about just inch by inch improving something and making it very slightly better. And at a certain point, it reaches the point where digital photography blows Kodak out the water, or the smartphone blows Nokia out the water, Nokia having blown landlines out the water. So there are disruptions. But I think if you're constantly expecting to be the disruptor, you'll mislead. You're much better off trying to find an incremental improvement that you can build on. What was the second point you made in that question? Because I wanted to come back to
it. Was about necessity and war, and
Yes.
those sorts of things.
Yeah, I really looked hard into the history of the computer during World War II, because there is a bit of a legend out there that it was the need to track the trajectories of artillery shells and decipher German German coded messages that brought the computer into being. And I came to the conclusion it's the opposite, that actually the annus mirabilis, the miracle year for the computer, if there was such a thing, is 1937, when both in Germany and in Iowa and in a couple of other places, there were remarkable breakthroughs towards the sort of programmable machine that we ended up with, which, had they been able to come together over the next few years, would have led to spectacular computing in the 1940s. Instead of which, you've got these secret projects going on that didn't even know about each other. So there's Turing in Britain, but in America, there's an amazing bit of work going on in Philadelphia with a non-electronic but programmable computer, and there's another amazing bit of work going on at Harvard with a electronic but non-programmable computer. And you're longing for these two to get together, but they're not allowed to know about each other because of wartime secrecy. There is one man going between the two who does know about both, Johnny von Neumann, and he is, of course, a key figure in all this. The way so what you end up with is, you get some devices that calculate the trajectories of artillery shells. Well, can't we think of something more exciting to do with a computer? If we'd had peacetime, I think we would have done. Right. Sure, radar probably got accelerated by war. Nuclear weapons certainly did, and various other things. But I think the counterfactual of what the 1940s would have looked like if it had been a peaceful decade is not an easy one to tell. It might have been an incredibly interesting and productive decade, and we might have ended up with advances in aeronautics and everything else that was fantastic, but just more peaceful, less military.
Yeah, no, I think that's an important one for us to think about, right? And another problem that I've been thinking about, I've been talking to a number of scientists over the past few years, and one story that comes up often is the idea that you need to defend basic science, mainly because it is going to result in serendipitous innovation in the future. Sort of been making the case for why we should fund basic science and not just chase after, say, innovation. But I think you have a counter argument to that as well, and I think an account of innovation that doesn't quite happen this way. That it's not always a result of after the fact serendipity that results from some previous basic science.
Well, I have two problems with that argument. The first is that it devalues basic science.
Yeah.
Frankly, if the only reason we're doing astrophysics is in case it allows us to invent non-stick frying pans, then that's not good enough. Black holes are interesting in themselves. It's a terrible pity if we're just going to measure the value of basic science as something that provides the input to technology, because sometimes it does, but that surely it's a higher calling than that. I think the discoveries of science are humanity's greatest achievement, bar none. I'd rather have deep geological time and space and double helix than Shakespeare and Rembrandt, frankly. That's it. I'd rather have both, but
right. Well, there's a profound beauty in both of them, right? And that's
If you look at the history of technology, it does not always start with science. The arrow quite often goes the other way. So the science of thermodynamics came out of the steam engine, not vice versa. A lot of cybernetics and things like that came out of computing, not vice versa. You don't need to understand the principles of something to invent it. Quite often we don't. There's a lovely recent example, which is gene editing, this CRISPR technology for editing genes, which is basically a bacterial immune system that we've adapted to turn it into a tool to make precise changes in genes. That began life as a discovery in a university, but only because the university at Alicante in Spain was studying salt-loving organisms, because there was a big salt industry next door. Okay.
Yeah, right.
It then moved into the yogurt industry. And the yogurt industry, the industrial biochemists in the yogurt industry started looking at this because they realized they were looking at a bacterial immune system. And in yogurt, bacteria are very important. You don't want them to get sick. So you want to understand how they defend themselves against viruses. And it was only after that that it goes back into a university in the form of Jennifer Doudna and Emmanuel Charpentier, who got the Nobel Prize, and also a guy in Lithuania who did the same work at the same time. And they say, hang on, we can repurpose this tool to change the genes in cells. And then a guy at MIT says, and I can even do it in mammalian cells and therefore in human beings. That work is indeed done in universities. And it does lead to a great technology that is now being applied in medicine. So that one has jumped between academia and industry in a sort of a two-way fashion. And that's a much more typical pattern, actually. That scientists discover something, people apply it, the application needs scientists to explain what's going on, that leads to another insight, and so on, rather than the linear model of the job of scientists is to feed pure knowledge into the top of a pipe, and out the bottom of the pipe comes technology.
Yeah, well, that's very helpful. One of the things we're trying to explore in this season of the podcast is not just the beauty of innovation, but also its burdens. And I wonder if you might be able to say something about the downsides, unintended consequences, challenges, etc., of our innovations. Particularly, so I mean, AI is one that everyone's talking about these days, and the kinds of risks it poses, etc. But
social media is one of the great innovations of my lifetime. At first, I thought it was simply wonderful. And it was a riposte to those who said computing is a lonely process. Actually, what were teenagers using their smartphones for? Rampant social engagement.
yeah,
Okay.
yeah.
And so it's the opposite of lonely. And also, it was going to enable us to see each other's point of view. Do you remember that? The marvelous thing. I can look up what anybody thinks on anything. And I won't remain stuck in my own silo.
Gosh.
Well, it didn't quite work out that way, did it? And some of the things people said about social media in the early days of the 21st century were very similar to what some of the things they said about radio in the 1920s, very utopian. And radio, again, brilliant, wonderful technology, but the dictators kind of made use of it. Mussolini, Hitler, and so on. Those are both examples of technologies that we thought were going to be unalloyed goods, but turned out to be a mixture of good and bad. I wouldn't want to disinvent social media. I wouldn't want to go back to a world without it. I think the good does outweigh the bad. And I think the same of radio. But I do think we need to, as in radio, we kind of learnt how to tame it so that it wasn't just being used by demagogues to stir people up. And we kind of need to learn to tame social media. I suspect the same will be true of AI, in that it will mostly be good. It will speed up and bring down the cost of drug discovery, treatment. It'll help people who are bad at things more than people who are good at things. I mean, it's already doing that, and it's improving the linguistic skills of people who have trouble writing much more than it's improving people who are good at writing. So it's a leveling up phenomenon, not a leveling down one. So I'm very utopian in many of the things I think about AI, but I'm also acutely aware that it's being used to produce some very nasty hallucinations, weird effects, and it's not impossible that it'll turn malevolent. I'm generally not that worried about the malevolent AI point, not as much as some people, because I think they don't understand evolution. And evolution is a competitive process, and there's no reason why a malevolent AI should necessarily become a monopolist. Malevolent viruses or parasites don't take over the world. They are a problem in the world, but they don't win out altogether. And I don't see AI monopolies developing. I think what we'll see is AI diversity, which will include some malevolent actors, but also some much more benevolent ones.
Yeah.
So in that sense, I am, as you can tell, much more of an optimist about AI than a pessimist, but it's not going to be without its bumps along the road.
Sure. Yeah, I know. And then, I mean, I think one of the big concerns is that it's de-skilling us in a number of important ways. And I wonder whether some of the conditions for our capacity to innovate are perhaps being threatened by or eroded by some of these new technologies, along with, say, the political and economic systems that are set up.
It's going to do the innovating for us, so we don't need innovators.
Could you, I mean, you talk about freedom as being a critical factor for innovation. Could you talk about perhaps if you could, maybe change one thing about or emphasize one direction in which universities and firms and governments could shift things in order to improve our capacity for innovation? What could that look like?
It's a really good question, and I don't think I've got a silver bullet of an answer. If I did, I'd probably patent it and
Right.
and not go on podcasts and blab about it.
Right. Yeah, you wouldn't be sharing it freely with others.
Well, no, I don't really believe in patents. Actually, I'm not a great fan of intellectual property as an incentive for innovation.
Could you say a word about that, actually? Because that is another controversial point.
Yes.
Yeah.
You can obviously make an argument that if you don't get some kind of monopoly profit from your innovation, you're not going to do it. But if you look at the actual history of the world, on the whole, patents quite often get in the way because they give one person way too much credit, not his predecessors and successors. And he then spends an awful lot of his energy defending his patents in court. So the guy, Samuel Morse, who invented the telegraph, ruined his life by suing everybody for the rest of his life because they'd infringed his patent. But the Wright brothers actually did something pretty similar. Marconi did the same. It can be a distraction pursuing your patents and also when patents expire, you tend to get a flourishing of innovation. The 3D printing patents have recently expired, and that has resulted in a surge of new applications of that technology. So on the whole, I think we have made intellectual property too restrictive and too easily used in a defensive rather than an offensive way. And we've had whole industries, basically the software industry, where patents haven't played a role at all. Nobody's bothered trying to patent innovations in software mostly over the last 50 years. It's not quite true, but it's mostly true because it was just far too fast moving a field. You were so out of date that your patent was useless. And copyright, which is a form of patent, is something I obviously benefit from. My books are copyrighted. But I think in the counterfactual world where I didn't have copyright, I'd still write books and I'd have to find a different way of making money out of them, like live performance on radio shows like yourself, where you'd pay me.
Right. Sure. Sorry.
You're not doing that, I assume. Because that's what musicians have done. They've stopped being able to rake in the money from CDs, and they have to go and do live gigs instead.
Exactly.
But they're not exactly stopping doing it, are they? Whereas, thanks to a change in the law in Britain, copying what Europeans did, but at the behest of American corporations, my grandchildren will be earning money from the sales of my books, if they're still in print, 70 years after my death.
Right.
Well, what did they do to deserve that?
Right.
They don't even exist yet, but they've certainly not contributed. And, that's not the incentive why I write a book, is so that my grandchildren have, a few tens of pounds in 60 years' time. More than 60, because I'm still alive, more than 70. You can see that I get quite exercised on the question of intellectual property. I think we've taken it too far and made it too restrictive. But back to what should we do, which was your question. First of all, teach this point that anybody can innovate, that it's a question of perseverance and experiment, not genius. Second, teach the point that it's incremental, not disruptive most of the time, and you shouldn't be trying to invent the next search engine or the next AI. You should just be trying to marginally improve something that's out there and produce a decent product. And thirdly, get away from this linear model that the purpose of science is to feed innovation. Try and set up a two-way system between industry and academia. If I ran a university, I would encourage professors to go off and work in industry and come back, students to do the same, industrial leaders to come and teach in universities. I would be swapping people with the private sector the whole time. I think that's going to be a really better way of achieving innovation than having these two very separate worlds.
That's amazing. Great. Matt, thank you so much for your insights. Is there anything else that you might want to share with our audience? Perhaps a point about your books that you wish people had asked you in podcasts and no one's asking you? Anything? I think you really want to communicate that you've not been able to perhaps satisfactorily do so. And
I don't think so. I think I've banged on long enough, and you've asked some very nice questions, which I greatly appreciate. So I'm quite happy to leave it at that. I actually recorded the audiobook for this last book. I enjoyed doing it. It took 3 days in a studio. I wasn't very good at it, but I, made a lot of mistakes. But kind editors cleaned that up. And I listen to more audiobooks than I read books now. And I think that is a big part of the future of books. People in the car, people at night who can't sleep, people doing other things, people going for walks. I think the era of the audiobook is a really interesting phenomenon, much more important now than the ebook. 20 years ago, we were all talking about the ebook. Now we're talking about the audiobook.
Yeah. Well, I listened to your How Innovation Works on audio, which I thought was really, really lovely. So,
I recorded that one too. You're right. And that was at the start of the pandemic. So I was locked in my linen cupboard, which had great acoustics, you see.
Yeah, not very comfortable, but wow, yeah, no, it's great. I really enjoyed that. So, Matt, is there anything that you're working on these days? A new book on the horizon, perhaps, or anything you want to share with our viewers and listeners?
I'm working on another book, but I'm not talking about it yet because it's not coming together yet.
Okay, great. Well, where can we point our audience to learn more about you and about what you're working on?
I do maintain a website, but not very well. I'm on Twitter at Matt W. Ridley, but also I'm increasingly working with a website called the Rational Optimist Society, which is based on the phrase I used for one of my books. And there's some great stuff about innovation and technology on that site.
Fantastic. Well, Matt, thank you. It's been an honor.
Thank you. You've asked some lovely questions, and it's been really nice to talk to you.
All right, folks, that's a wrap for this episode. If you enjoyed the episode, please share it with someone who would find it of interest. Also, please subscribe and leave us a review if you haven't already. Thanks, and see you next time.